Hey guys, just way too beautiful to not try and take advantage of this weather, so I'll be taking you today the process of a eukaryotic cell converts glucose to ATP. So the first step in that is glycolysis. So this takes a single glucose molecule and we end with two 3-carbon sugar called pyruvate. So the process that uses that is two distinct phases and they're both energy requiring. The first part traps the glucose molecule in the cell and uses energy to modify it so that the 6-carbon sugar can be split evenly into two 3-carbon molecules. That's the energy requiring part. The second part extracts the energy from the molecules and stores it in the form of NADH and ATP. So we start with the glucose, we produce 2 pyruvate molecules, 4 ATP molecules, and 2 molecules of NADH. Next, we have the oxidation of the pyruvate. So if oxygen is available, the eukaryotic cell can continue aerobic respiration. The pyruvate produced in the last step will be transported to the mitochondria. There it is transformed into an acetyl group and activated by CoA. The result is acetyl-CoA. Its main function is to deliver the acetyl group to the next stage in the process, which is the citric acid cycle or the Krebs cycle. This process takes place in the mitochondrial matrix. The acetyl-CoA is attached to oxaloacetate to form a citrate molecule. So through a series of oxidation steps, CO2 is produced for each acetyl group oxidized. So NADH is reduced to NADH, or NAD plus is reduced to NADH, FAD is reduced to FADH2, and 1 ATP. So after this cycle completes, the final product, or the final reactant is also the very first reactant. So the cycle can keep going as long as there's sufficient reactants. The last step is the oxidative phosphorylation, through which a process called chemoosmosis occurs. It begins by moving electrons through a series of electron carriers in the mitochondrial membrane that shuttle electrons from NADH to FADH2 to oxygen. This causes hydrogen ions to accumulate in this intramembrane space, forming a concentration gradient. Here, the hydrogen ions diffuse out of the space into the mitochondrial matrix by passing through the ATP synthase, with one of those byproducts being water. The current of hydrogen ions powers the catalytic action of this ATP synthase, which phosphorylates ADP, finally producing good old ATP.